Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from VG Soma IIT Kharagpur who is taking this course. We are in week 10 and this is session 3. We are discussing about text mining in the context of marketing. So, if you see the file, there is something called basic tdmcode.r. I have to thank my friend Mr. Saptarshi Sarkar for sharing this file with me. The actual file has been made by him, but I am using this for the course and I think he has given me the permission. So, the first thing in this particular thing, in this particular class what we are trying to do is that we will play with some text data, and this text data is available online, freely available text data, and it is about Martin Luther King. I have a dream speech. So, that particular speech is what is there in the text, and we will try to analyze that. So, to do that, there are certain libraries that you require. You require a library called TM, then Snowball C, Word Cloud, and R Color Brewer. We will discuss about them one by one. So, first things, we have to check that whether these libraries are already installed or not. So, I can see probably TM library, if you can see here, the TM library is not installed in my this thing. So, I will try to call this library and it will say that error, there is no package called TM. So, what I am going to do now in the next probably 2-3 minutes is to install all these packages. So, install dot packages, then TM comma. So, we have to install quite a few package. So, TM, what else? Snowball C. So, S capital Snowball C, and then the next one is Word Cloud. So, Word Cloud, and the next one is R Color Brewer. R is capital, C is also capital, Color, and then Brewer, BREWER. So, let us just install these files. So, it might take some time depending on the internet connection. So, TM library is the classic library that we will be using, and it has dependency called NLP and SLAM. So, it has downloaded that, and the other ones have also been downloaded. So, if you see that NLP, SLAM, TM, Snowball C, Word Cloud, and Color Brewer all have been downloaded. So, if I now call these 4 libraries together, I think they will work. So, some of them saying that was built under 3.6.3. So, TM build was 3.6.3. So, you have to check whether your R version is compatible to this, but warning sign means it is okay, we can go ahead. So, I have till now what I did is I installed certain libraries. Then what I will do? Then I will actually not set working directory. So, this I will delete, and then I will set working directory to my source file location, wherever this file is currently residing, this code file, and then I am putting this thing that file path is equal to this particular link. So, if I just go to the link, what does it look like? Let us just check that. So, if I just go to this link, so in this link this whole text is there. I can probably make it bigger and okay. So, even though we face the difficulties of today and tomorrow, I still have a dream. It is a dream deeply rooted in the American dream, and so on. So, the great American dream, Martin Luther King's speech. I have a dream that one day this nation will rise up and live out the true meaning of its creed, blah 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 is given. That particular thing is written in this particular. So, we can read a text, it could have been some other file also. So, there are different ways to read files from internet. Text we can directly do that. So, I have to give file path. So, file path is basically the link of this particular data, that is my file path, and the text is read lines. Read lines means line by line it will read. So, read lines file path, and that gives, if I now see the text, it will see the line by line it has written. So, the first line was blank, and then so even though we face the difficulties of today, tomorrow I shall have a dream, that comes in the second line. Third line was also blank, because if you remember, if you remember how the text was there, you will see that the first line was blank, and then second line onwards there was some text, as there here it was blank, then some text, then one blank, then some text, then again blank, then again text. So, one single line by line it will just try to read. So, whenever you press an enter in the text, when whoever created this text document, whenever he has pressed an enter, another line got generated. So, if that line was nothing written in that, then that line is blank, and then you go to the next line. So, that is how we did this thing. So, I have some blanks and some text in this particular data. Next what? Next I will change this text data, which is a character variable, to a data frame. So, as data frame text df is equal to as data frame text. It is nothing but one single observation, the same things with some blank values and some text values are there. Why we do that? Because I can now save this. So, I will save this in my file, wherever the files are stored. I can save this, so that next time by chance the internet is off and I want to do the this thing once more, I do not have to read the file again from internet once more, because if internet is not there, then there is a problem. So, this is how the data is now saved here, text underscore df. Okay. So, if you check it carefully, here there is another column that has come up, which is this 1, 2, 3, 4, 5 things, these things have come up. So, these are basically row names, and there when there is no row names, the serial numbers of the rows comes up. If you do not want that, you have to write .csv text df, then csv, and then row names, row dot names is equal to false. You can write this, that comma row dot names is equal to false. It will just append the previous thing, and now see there is no row names. So, 1, 2, 3, 4, 5, 6, 7, 8 has gone. So, this is something that you can try to do. Now, what I will be doing is that my text 1, I am reading the text once more. So, text 1 is equal to read.csv text underscore df.csv. I am reading the text once more. Why I am reading the text once more? Because now I can play with this text. So, this is the text document that I have got. So, if I just want to see what are the texts that are there, that is basically text 1 dollar, text is the column name. So, text 1 not found, sorry, text underscore 1, text underscore 1 dollar text, and that is this text. This is what I will be playing with. Now, once I have a column of data set, there is something called corpus. Corpus is a special form, like if you remember, factor was a special form of string variable, where you can analyze the string data with numerical representations. Similarly, here this text underscore df is one kind of a data set, whose text I can convert to something called corpus. Corpus is a special form which can be worked with TM library. TM library can easily analyze this corpus form of the data, and this is generally text data, and corpus can be formed from text files, from CSV files, from PDF files, from folders. If you put lots of folders inside, lots of text documents inside a folder, and then if you read a folder and then change that folder's content into corpus, that can also create lots of text. So, it is basically a bunch of text put together in its very raw form is called corpus. Why it is required? Because it reduces size, and the moment it reduces size, you can actually analyze the data with faster speed and lots of accuracy. So, I will first change this data to its corpus corresponding. So, if it is vector source, because my column there is a column of data, when for other things this vector source things will change. But now, because they are in vector, in most of the situation in marketing, you will get customer reviews, let us say, and customer reviews will be in a column, or blog reports will be in a column. So, that can be a vector, and you can use vector source as your function to convert the vector wise string data to a corpus data. So, this is what we are doing. The first thing, I am creating a docs. So, if you check, there are lots of things are there in docs. So, if I just inspect docs, this is how it looks like, and in a long this thing it will be very difficult to inspect the whole thing. So, docs has what? Docs is a metadata which is a corpus specific is equal to 1, document level 0. So, it is not indexed, and the documents is 45, there are 45 documents. And if I inspect, let us say first 10, generally that is what we do, because the corpus in real life situation will be very long. So, then I say let us say 1 to 10, I get the oh sorry, not this one. So, if I just write within docs, yeah. So, I get the first 10 documents in this thing, fair enough. So, that is how we create the corpus. Then there are lots of things that we have to do. You have to understand that there are some changes that we have to do. So, we are doing content transformation. So, content transformer, we are transforming some content. How? So, it will be doing this thing, that particular function is called toSpace. What it will do? It will be basically a function of x and pattern, where it will change a pattern with a blank. Whenever you give a source a pattern and a blank, it will change that in this source called x, it will find out a pattern, and corresponding pattern it will replace it with a blank space. For example, this is a function, just a function that we have written. For example, let us say doc, I am writing tm underscore map, and then docs toSpace, and then this. So, whenever this particular sign comes up, it will use this toSpace function here, okay, and that is how it will convert it. So, that means it will convert this whenever this particular backslash is coming up, it will convert it to a space. So, this is what I am writing. So, convert all these punctuations, this one, and then this one, and probably this one also, all of them to space. That means that they will be blank spaces. Now, if I try to inspect, if I just try to inspect, you will see that those kind of signs are probably removed from the data, and there are space things that are still there. So, you have to check that whenever this particular thing was there, and now it has got removed. So, that is how we are slowly cleaning the data, so that the data can be used for further analysis. What next? Now, there can be so many different kind of transformation. Why this transformation is needed? Let us say somebody says that there is Martin Luther. And some other guys have written Martin Luther, and there is some other guys have written M. Luther. So, ideally these three texts will be different, or M. Luther might be should be different actually. M I am not saying, or let us say this one. So, that M. Luther will be different in any way, but let us say Martin and Luther. Now, how do you deal with this kind of a situation? You think that, see, all these three are different, and if you ask the guy to analyze it, it will analyze it differently. And you have a problem that you do not know that whether you should analyze them differently or not. There are situations where you want to analyze them differently, there are situations where you do not want. If you do not want, then if you want to analyze them as the same thing, then what you have to do? Basic thing, you have to change all of them to their lower form. So, let us say I write all of them becomes Martin and then Luther, something like that. So, to do that, what I have to do is convert them to their lower form. So, that is something that I have to do as the first. So, I am here, if you check the text, I am converting them to their lower form. Docs is equal to TM map docs content transformer to lower. So, this is something that I am doing for the first thing. Done. If I now inspect my content, so let us say docs. If I inspect docs, everything is in lower case. Everything, all the text is in lower case. There is nobody which is in upper case. Then what? Then there are certain things which are numbers. So, I will just check whether numbers are there or not. In this particular text, numbers is not there, but number is probably very standard cleaning procedure that we have to follow, because sometimes we have numbers. I would say pretty often times we have numbers. Here we do not have numbers, but still if you have to remove numbers, the code is like this: doc tmmap docs is comma remove numbers. So, you pick up docs, that particular corpus, find out the numbers, remove them, and then again save it in docs. So, that is what I am doing. Then what? Then there is something called stop words, and we are focusing on English language. So, stop words underscore English, stop words within bracket English. So, I will just copy that and paste it here. So, these are the stop words. What are stop words? Stop words are basically unnecessary words, words which have no contribution or more frequent, less meaningful words are basically stop words. So, this we have to remove to reduce the baggage. So, if my data set has lots of baggage, baggage means unnecessary words, then what I feel is that I feel heavy, I cannot analyze, and sometimes the insights generated are not so useful. So, we have to remove stop words. Now, you can remove stop words by just mentioning that some of the cases there can be certain words which itself are stop words. For example, if you remember, I told in a hotel review context, one stop word itself is hotel. This itself is a stop word. So, if this itself is a stop word, then that particular thing has to be removed, because hotel is very common. If we do TF IDF, the guy's DF will be so high that TF IDF score will be much low. So, in such kind of a situation, we have to remove them. So, this is something that I am doing now. These are my stop words, and if you want that, okay, there is one more stop word which is hotel, let us say. So, you say let us say, so remove stop words is TM, then docs is your X, from where you will remove. The function is remove words, and what will you remove? Stop words and then this English. So, if I just run this, in the whole docs, these particular words have been removed. So, thank you almighty free last, every mountainside let freedom ring. So, there are certain words you can understand now, let freedom ring every hill. So, let freedom ring probably from every hill was there to another to hill Mississippi or something like that. So, that kind of to form the all the pronouns, all the prepositions, conjunctions has been removed. Let us say in this particular thing I also want to remove this let. This let is coming very common and let has no meaning for my case. So, let us remove let. So, how will I remove let? I will just create docs and here instead of stop words I would write let. Let has got removed. Now, in my instead docs see let freedom ring blah blah blah, this has also gone away. Now, let us say I want to remove two words instead of one word. What will I? So, will, let us say will be free, will be the day, will be able to. So, will has nothing to do and then there is another word let us say which is let us say another word can be will is one word, it is coming up pretty common. Also, for will and for, this is another word that I will be removing. Let us just say that. So, then what I will do is here I will write C will and then for. Now, if I inspect the docs, the will has gone away and the for has gone away. So, all of these things are. So, that is how you clean unnecessary words. Now, after cleaning unnecessary words, so see here you see that blah 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 and blah blah 2 these words are not there, but this is how you can remove it. Some example has been given here. So, then the remove punctuations. So, remove punctuation. So, if you just run that and then if you inspect the document, all the punctuations in this document has been removed. So, that is what we are doing. And then there are white spaces also, blank spaces. So, TM map docs strip white space. So, that will actually remove all the white spaces, not the enters, but if you have given tabs in between, let us say A tab B. So, A tab B will create a situation like this, you write A and then a blank and then B. So, this blank will be removed by white space, remove white space. So, after this cleaning, this part up to this part, it is called pre-processing of the data. After this pre-processing, what we try to do is the first thing that I will do is we will create a document term matrix. What is document term matrix? Document term matrix is something which looks like this. Let us say I have in the whole corpus, I have m unique words and n observations, that means n number of variables, m number of unique words and n number of observations. So, what we do in this case is a m by n matrix, where here each word is written word 1, word 2, word 3 up to word m. So, each word is given here and correspondingly we just see that in observation number 1 whether some other word has occurred or not, or how many times it has occurred. So, this has occurred 2 times, let us say 0 0 1 0 0 something 0, and then in the second entry 0 0 2 1 0 0 0. In the third entry it is 0 0 0 1 1 1 0 and the fourth entry and so on. These are basically frequencies. So, this particular matrix is called document term matrix. Generally, we do not convert this matrix to visible matrix form. What we do is a special form of matrix which is document term matrix, and I will tell you what that particular thing means. So, this is something, and the purpose is also something that I will tell you. So, DTM converts is to document term matrix, and DTM is this thing. If I by chance convert DTM to its matrix form M, then the M will look like this. See, there are so if you check here 163 unique text is there, unique words are there, and this 1 to 45 is the number of observations. So, sorry, in the other way, it has done in the other way. So, 163 unique rows are unique words are there, which are rows, and 45 columns are there, and this particular column is particularly saying that in the first row which words are occurring. So, 1 1 1 3 1 1 1 1 1. So, which words are occurring? So, if I do the row sums of this particular matrix form that you are seeing, then what you will get is the whether this particular what is the total frequency of that particular word, you will get that. But actually in document term matrix, if you see, what is DTM? DTM gives me the I, the J and the V. See, remember, if it is a if there were m number of words with 45 observations, I got 163 unique words. So, now if I have let us say around a data set of 5000 observations, then how many unique word will I have? I will have probably 10,000, 15,000 unique word. So, then 5000 into 10,000 matrix will be so big a matrix that analyzing that will be a difficult. Analyzing, forget about analyzing, reading that in your R will be a very hectic thing. So, then and also you have to remember that there will be lots of zeros. You see that you see this particular document term matrix, most of the words are not occurring in a particular observation. In a particular column, probably at max 100 words will occur, but you have 5000 words. So, in a particular observation, maximums will be 0. So, if there are lots of zeros and some of the positions where these numbers are positive, then why don't I do this? So, instead of let us say creating, let us say I have a 5 by 5 matrix, 1 2 3 4 5 1 2 3 4 5. Let us say this is 0 1 0 0, this is 1 1 0 0 0 0 1 0 1 0 0 0 0 0 1 1 0 0 1 0. Let us say this kind, maximum 0, a few 1. Instead of writing this thing, can I write that these are my i's, these are my j's and these are values. So, I is equal to 1, then I is equal to 2 2, then 3 3, then 4 and then 5 5, and j is equal to, for the first one it is 3, then 4, then 5, then 2, then 4, then 5, then 1, then 4, and the v which is value is all 1, or let us say this is 2. So, 1 1 2 1 1 1 1 1. But how do I read this? These are 3 vectors. How do I read this? So, the first entry is I is equal to 1, j is equal to 3, value is equal to 1. So, first row, third column, the value will be 1. The second is second row, fourth column, value will be 1. So, second row, fourth column, value is 1. Second row, fifth column, value is 2. Second row, fifth column, value is 2. And that is how you create the matrix. And exactly now, this formation of matrix takes less space. You have equally whatever information you have here, you have the same information you have here, but it takes less space. So, to do that, this kind of a document term matrix, you see I, j and v, that values ith which so that values are given, and then you can calculate it. So, that is what we have created. Now, I have created the matrix formation of this particular observation also. In real life situation, this matrix will be so large that you will be not able to see like this. So, suggestion is you do not do this conversion. Now, the row sums will be the basically the, as I told, the row sums will be the values. So, if I see that the most common this thing is freedom, because Martin Luther King, he will talk about freedom, right. Then ring, then dream, then day, one day will come, that day we will do this, that day we will do that. So, day was, so every morning will be very good. and blah blah blah. So, these kind of words were coming at the top. And then if I convert this to a data frame where frequency is equal to V and the data is equal to data, the data frame D looks like this, the words and their corresponding frequency. So, this is called the document term frequency data set. So, we can create this data set, the same thing in a much smaller code also. I will show you at a later video that how to do it in a smaller code. And now, with this D, what I will do is I will ask you to plot a simple bar plot which looks like this, which is basically talking about which words are common and which words are not common. So, here what I have done till this point is actually we have read the data, we cleaned the data, pre-processing of the data has been done and we created a bar plot to show that which word is most common, which one is less common, how to find out the term frequency of the words we have found out. In the next video, we will try to see that how this kind of concepts can be done, can be used for analyzing the data in a better way. Thank you for being with me. I will see you in the next video.